Hi, my name is Dennis Chin, UR14CS319, and I'm here today to explain the 10th experiment of UNIX Lab, which deals with interprocess communication using shared memory. So our aim is to write a program to demonstrate the interprocess communication between two processes using shared memory. What exactly is shared memory? Shared memory is an efficient means of passing data between the programs. One program will create a memory portion which other processes, if permitted, they can access. So one process can create the memory portion, and the other process can access it if permitted. Moving on to process one. Okay, since it's not working, I'll just yeah. Process 1 creates a shared memory and writes some string into the shared memory, then waits for the process to read and modify the shared memory content. Okay, so we have our header files here, followed by the main program. We give our variable as key, and we input the key from the user, and we have a call here, int shmid is equal to shmget key 100 IPC create 0764 pipe 0764. So this shmget function returns the shared memory identifier associated with the key. The shared memory identifier and the shared memory segment of at least size bytes is created if key is equal to the IPC create or IPC private. So there are three parameters: key, size, and SHM FIG, the figure, and the key specifies IPC private or unique key. The second parameter would be their size. It is the size in bytes of the shared memory segment. And lastly, the SHM FIG specifies both the creation and the permission bits. Okay, so if SHM ID is less than 0, then we have not created. Else, we have a statement saying it is created. Then we have a pointer, virtual address character, virtual address of type character is equal to character pointer shmat shmid 000. What is shmat? shmat function attaches the shared memory segment associated with the shared memory identifier shmid to the data segment of the calling process. The segment is attached to at the function specified by one of the following criteria. The null pointer, it could be a SHM ADDR, could be a null pointer, it could not be a null pointer, and yeah. So there are a few parameters. The first one being SHMID, which is a unique positive integer created by SHMget. Then we have our SHMADDR. This points to the address, the desired address of the shared memory segment. Lastly, we have our SHM fig again. We specify the set of flags that indicate the specific shared memory conditions and options to implement it. Then we have our character string. String is equal to virtual address, cout string we print the value of string, followed by the data that needs to be reversed. We input the data using CIN, and we put the process to sleep for 5 milliseconds. And then lastly we print the data to be reversed statement. Moving on to process 2. Process 2 gets the shared memory created by process 1, and it reads the string and displays the actual string and the reverse of the string, and also it modifies the content of the shared memory. So yeah, we have a few statements here. Include IOStream, the header files here, using namespace std, int main, in key, cout enter key. We enter the key once again. The shm get key, the parameters are given inside shm get. If shm get is less than 0, it's not created, else it's created. Likewise, we said before, shmat is given here with the virtual address equal to the virtual address for the pointer. Str is equal to set to the virtual address, and here we have string str1 into the array. String str is equal to an empty. Int1 is equal to str1 dot size. The size of str1 is set to into L. For an int I is equal to L minus 1, I is equal to is greater than or equal to 0, and you decrement the value of I. Next, we set the value of str1 in i's position plus str equal to strr, and then we use a string copy function to basically serve as the variant of this program, c underscore str parentheses, and then lastly you print out scout the string. So this right here would basically reverse the given input from the previous program in which we inputted the string. So this would take that and reverse it. And so yeah, so here when I executed my program, I have this vi10. We're told to enter the key from last time, and once we enter the key, the process gets created, and the reverse of what I gave before gets printed. Before I had given the string as nix, and the key was 30. So using that same key in process 2, I'm able to enter the key and get the reverse of this string. So that's it for our 10th program, interprocess communication using shared memory. Thank you.